Now that we've run the monolith, let's look at its underlying implementation. Everything that we really care about is contained within the single main.swift file. At the top we have our dependencies. To begin, we have Katura, which provides routing and middleware that can be applied to the different endpoints. Then we have the Helium Logger and Logger API so that we can log messages that we'll ultimately use for debugging. I should mention that unlike an iOS app where log statements may or may not be used in production, on the server-side logging is very important and crucial. Once a server-side app is deployed, log statements give us vital insights into the running server, which, for example, can tell us things like if requests are being successfully routed or if the user logged in. This becomes even more important when you have multiple microservices coordinating with each other and you need to be able to group log statements together but still uniquely identify them. One other thing to keep in mind with logging is that you should never log sensitive information because log files could be compromised at some point. The next dependencies are credentials and credentials HTTP, which provide basic username password middleware that allows us to require a username and password like we've seen for the login endpoint. Then we have Perfect Crypto and Foundation. Perfect Crypto is for public key cryptography, and Foundation gives us classes like date, which we need further down in the source. If you're not familiar with public key cryptography, then here's a quick overview which we'll talk about more deeply later on. You start with some message or data that you want to send, and you want to ensure that if the message is intercepted by someone with malicious intent, that it cannot be understood. So, you encrypt the message using a secure private key, converting it into what is known as ciphertext. Ciphertext obscures the original information such that it's not readable by any human or a computer unless you have the proper public key. Ciphertext can be then sent over the network without fear of being understood by anyone eavesdropping on network traffic. Once the ciphertext arrives at its destination, it can be converted back into the original plain text message using the public key. Back in our code, starting here at line 12, we see where the public and private keys have been hard-coded, which we've done for demonstration, but would never be recommended for a production service. I'll repeat that again. Never hard-code public or private keys into your code base. Bad idea. Now we'll deal with it for now, even if it makes us a bit squeamish, and later on we'll show the proper way to handle public and private keys. Moving down, the next lines create the Helium Logger with a log level of .info. Then we get into the really juicy part of the monolith, the middleware. In total we have 3 different middlewares. We have a middleware for checking basic username and password credentials, here at the top from lines 20 to 31 in this example. We have a middleware for checking for the existence of a JSON Web Token, or JWT, and that starts here at line 33, and if we go down, it ends right around here. And finally, we have a middleware for logging. So let's look at this logging middleware because it's the most simple. It implements a single handle method, which is defined in Katura's router middleware protocol. This method allows a middleware to handle a request prior to it being passed along to the request handler or another middleware. Visually, you can think of middleware like part of an assembly line. When a new request enters the assembly line, it passes through any existing middleware before reaching your request handler. When the request arrives at a middleware, the middleware can inspect or augment the request. Also, the middleware must ultimately make a decision about whether or not the request should be passed along to the next stop on the assembly line. So, for example, if the middleware in question is a credential checking middleware, then it could inspect a request to determine if that request does or does not specify the proper credentials. If the credentials are not valid, it could then stop the request from continuing any further and pass an unauthorized response back to the location where the request originated. On the other hand, if a request makes it past the credential middleware, it is forwarded to the next stop on the assembly line until it reaches your request handler that can make the final decision on what to return. In our example, the logging middleware simply takes the request, logs some basic information, and then passes it along using the next function. The JWT middleware is a bit more complex. It checks for a proper access token where the access token is a JSON Web Token, or JWT. So we have this internal function for send auth failed. Let's scroll past it. And here we see where it's looking for the authorization header. This header is what contains our JSON Web Token. Now JWT is itself a JSON object, and it contains standard key value pairs that contain information about the token, like when it was created if and when it expires, as well as any custom key value pairs that we want to define. In this example, assuming we can find the token in the header, we start by decrypting the token using our public key. That's what's happening here on line 54. Once we've decrypted the token, we check for the existence of an issuer, issued at, and expiration key value pair. Now this actually isn't doing too much. We only check if the key value pairs exist. But for a production service, we may check if the issuer is the proper issuer, or make sure that the expiration date, we're not past the expiration date, and so forth. But for us, this is fine. Assuming the key value pairs exist, we forward the request along to its next destination. And that's what we do here on line 66. Otherwise, we return an unauthorized response. And that's what happens with the send off failed function. If we scroll up to where it's implemented, here we can see that when we send the response, we send it with the status of unauthorized. The last middleware is the basic credentials middleware. This middleware looks a bit different than the others because it is set up through the credentials object, which is defined in the credentials HTTP package that we included earlier. Instead of the default handle method, we create a credentials HTTP basic object and define a closure for the verify password parameter. This closure checks to see if the request contains a username password pair matching one of the pairs in our hard-coded users array. And this is where you can see that poorly named username password pairing. If a match is found, then we invoke a callback containing the username, a display name, and a string representing the credential provider. This callback effectively forwards the request along to the next handler or middleware. If no match is found, then we invoke the callback with a single nil parameter. The last thing we have to do is register the basic credential checker object with the credentials object that we created earlier. Okay, so that's an overview of all three of the middlewares, but how are they assigned and applied to the monolith's endpoints? If we scroll down a bit, we'll see. On line 88, the router is declared, and once declared, we can use the router object to specify the endpoints to which a middleware should be applied. So for the logging middleware, we want the middleware to be applied to every endpoint. So we specify for the path /star, which is something that matches every path, that we want the middleware request logger to be applied. Whereas for the login and secure endpoints, we have our specialized middlewares for credential checking. So for login, we have the basic username password credentials middleware, and for the secure endpoint, we have the JWT middleware. Visually, you can think of it like this. All endpoints start with the logging middleware. Then for the login endpoint, we have the additional basic credentials middleware, and for the secure endpoint, we have the additional JWT middleware. After all this is set up, we actually have our request handlers. The root endpoint is simple. It just returns a JSON message. And scrolling past login, the secure endpoint is pretty much the same. But remember, the middleware is applied before this request handler is reached. So with the secure endpoint, if a proper JWT is not present, then this code is never run. The last endpoint we have is the login endpoint. Assuming this handler is reached and a valid username and password are supplied, then we create a dictionary representing the values in our JWT. Using the dictionary, we attempt to create a JWT creator object, and if successful, we can use it to sign and send our JWT. And before sending it, we need to make sure to encrypt it with our private key. And that's the login endpoint. And then finally, at the bottom, we set up our server with a port and a router object, and we run it. And that's it. That's everything behind the Monolith service in a little over 100 lines of code.